Hello everyone and welcome to Photochemistry Lecture 8. In this lecture we are going to discuss about photoreduction reaction. Let's start our discussion with oxidation and reduction reactions. We know that oxidation and reduction goes hand in hand. What does it actually mean? Look at this figure. Compound A loses electron and gets oxidized. This process is known as oxidation. At the same time, B gains electron and gets reduced, and this process is known as reduction. Therefore, oxidation is loss of electron. A loses electron and becomes A plus. But where will this electron go? There is a reduction happening simultaneously in the reaction vessel, and that process accepts the electron. B plus electron gives B minus. So, A is getting oxidized and acts as a reducing agent. But why? A is giving electron and B is accepting electron and getting reduced. Therefore, A is helping B to get reduced, and so A is a reducing agent. On the other hand, B accepts electron from A, and as a result of which A gets oxidized, and hence B is helping A to get oxidized. So, B is an oxidizing agent. So, what is a redox reaction? Reduction plus oxidation together gives redox reaction. Redox reaction is transfer of electrons between chemical species. One species gets oxidized and other gets reduced simultaneously. Therefore, oxidation without reduction is not possible, and reduction without oxidation is also not possible. Therefore, oxidation and reduction goes hand in hand. Now the question is, beside defining oxidation and reduction in terms of electrons, is there any other definition for it? Look at this picture. Magnesium burns in oxygen and gets oxidized to magnesium oxide. During this process, the oxidation state of magnesium changes from 0 to +2. And oxygen oxidation state changes from 0 to -2. Therefore, oxidation is increase in oxidation number and reduction is decrease in oxidation number. In another situation, hydrogen reacts with oxygen to give two molecules of water. So, during this process, oxygen is getting reduced as it is accepting hydrogen, and hydrogen is getting oxidized as it adds to oxygen. Therefore, oxidation is addition of oxygen and removal of hydrogen, and reduction is addition of hydrogen and removal of oxygen. Therefore, let's just have a glance at the definition. Oxidation is removal of electron or increase in oxidation number or addition of oxygen or removal of hydrogen. Reduction is gain of electrons or decrease in oxidation number or removal of oxygen or addition of hydrogen. Now, what is photoreduction? Photo means light. Reduction is a chemical process in which there is either addition of hydrogen or electrons, removal of oxygen or decrease in oxidation number. Therefore, any reduction reaction happening in the presence of light is called photoreduction. We already know that carbonyl compounds have a tendency to abstract hydrogen. Where did we study? Yes, Norrish type 2. There we saw how carbonyl group abstracts the gamma hydrogen. Carbonyl compound can also abstract hydrogen from the solvent or any other hydrogen donor. One such example is photoreduction of benzophenone to benzophenacol. Look at this reaction. An aromatic ketone in the presence of light and hydrogen donor gets converted to phenacol. What are phenocols? Phenocols are 1,2-diols. Now let's look at the mechanism of the reaction. Here we will look into the photoreduction of benzophenone in the presence of isopropanol. Benzophenone in the presence of light undergo n-pi star transition to give excited singlet state where the electrons are paired. This singlet state goes to excited triplet state where the electrons are unpaired through effective intersystem crossing and give rise to diradical. This diradical abstracts a hydrogen from isopropyl alcohol to give benzhydride radical and hydroxy isopropyl radical. Hydroxy isopropyl radical is very unstable and have very short life. It immediately gives hydroxyl hydrogen to the ground state benzophenone and gets converted to acetone in a non-photochemical reaction. The benzophenone molecule, on the other hand, abstracts this hydrogen and gets converted to another benzhydride radical. Two benzhydride radical combines together to give rise to benzophenacol. Here are some questions for you. Number 1. What do you think is the quantum yield of the above reaction? How efficient is the reaction? Number 3. In the photochemical reduction of benzophenone in isopropyl alcohol, which molecule gets oxidized and which gets reduced? Which acts as oxidizing agent and which acts as a reducing agent? Number 4. Why is conversion of benzophenone to benzophenacol called a photoreduction reaction? What is the mechanism of the reaction? I have discussed the answers also. First, the quantum yield of the reaction is 2 because one isopropyl alcohol, as you have seen, have transferred hydrogen to two benzophenone molecules by absorption of one quanta of radiation. Secondly, the reaction is highly efficient. If you mix benzophenone and isopropyl alcohol in a vessel and keep in sunlight, after some time you will see that benzophenacol will precipitate out. Now tell me, in the above reaction, which compound gets oxidized? Yes, it is isopropyl alcohol which gets oxidized to acetone. Which compound gets reduced? benzophenone gets reduced to benzophenacol. As you know, compounds which gets oxidized acts as reducing agent. So isopropyl alcohol acts as reducing agent and benzophenone, since it gets reduced, act as oxidizing agent. Now why is this conversion called a photoreduction? Conversion of benzophenone to benzophenacol by abstraction of hydrogen from isopropanol is a reduction process happening in the presence of light, and so it is called photoreduction. The mechanism of the reaction is hydrogen transfer followed by dimerization. What happens if the same reaction is carried out in toluene? What do you expect? Will there be any difference in the mechanism of the reaction? Let's see. The initial steps are same, leading to the formation of diradical. The diradical now abstracts a hydrogen from toluene, and as a result of which two radicals are formed. One benzyl radical and the other one is benzhydryl radical. Now unlike isopropyl radical, hydroxyisopropyl radical, as we have seen in the previous case, benzyl radical is stable. So what happens? Two molecules of benzyl radical combines together to give rise to dibenzyl molecule, and benzhydryl radical, as in the earlier case, dimerizes to benzophenacol. It may so happen that one benzyl radical can combine with one benzhydryl radical to give benzyl diphenyl carbinol. Oh, who is this? A cute little girl asking you question. What is the quantum yield of the reaction? Why do you think benzyl radical and benzhydryl radicals are more stable than hydroxyisophenyl radical? What is the mechanism of the reaction? The answer to the first question is 1. Why? You think and come up with the answer. The answer to the second question is resonance stabilization. And the last question, mechanism of the reaction, is hydrogen transfer followed by dimerization. Now let's see what happens when the photoreduction of benzophenone is carried out in N,N-dimethyl-aniline. N,N-dimethyl-aniline can donate electrons. As the nitrogen of the aniline group has lone pair electron, and the availability of the lone pair electron is enhanced by the plus I effect of the two methyl groups. So here the mechanism of the reaction is not hydrogen transfer but electron transfer. The initial steps are same, leading to the formation of diradical. The diradical now gets an electron from N,N-dimethyl-aniline and gets converted to benzophenone anion radical. Next, a proton is transferred from the methyl group of the radical cation to the negatively charged oxygen of benzophenone anion radical and forms benzhydryl radical. 2-benzhydryl radical dimerizes to give benzophenacol. Okay, here is a cute young girl again with some questions. What is the quantum yield of the reaction? What is the mechanism of the reaction? The quantum yield of the reaction is 1, as here one photon can activate one molecule. And the mechanism of the reaction is electron transfer followed by proton transfer and dimerization. The next question is photoreduction possible in all types of molecules? It is observed that photoreduction does not occur in compounds having electron donating group. Example, methoxy group, as you can see in the first compound. Here, the lowest excited state is pi star state and not n-pi star state. And in this state, this state does not have the ability to abstract hydrogen. Another example is Mischler's ketone. On photoexcitation, it goes to the charge transfer state, and this charge transfer state do not have the ability to abstract hydrogen and so do not undergo photoreduction. But compounds having electron donating groups like cyanide, nitro, halides shows photoreduction very efficiently. But why? Should I give this as assignment? Today, no assignment. I will tell you a story. Supposing I have a friend Ria who has a house at Malabar Hills, very well maintained and beautifully organized. I want to give her a teak wood sofa as my entire family is shifting to Kolkata and I don't want to carry my furnitures. What do you think? Even if the sofa is of teak wood, which is supposed to be very costly, Ria will accept it? No. She is happy and comfortable with whatever she is having, and maybe the sofa will add discomfort and restrict the free movement in the house, or in other words, will bring instability. I have another friend, Meena, who is not well to do, and I offer her this sofa. What do you think? She will gladly accept this, right? So now I say, Ria be a benzophenone having electron donating group, and Meena be benzophenone having electron withdrawing group, and my sofa be the reduction process. So where will the reduction happen? Reduction will happen with Meena and not with Ria. Electron withdrawing group attached means the system is experiencing deficit of electrons, and so it will readily accept electron from any source and itself get reduced. But the situation is exactly opposite when an electron donating group is attached. If electron donating group is attached to the ring, then the ring is already experiencing an excess of electron, and so acceptance of more electron will bring instability in the molecule, which the molecule do not want, and so reduction will not happen. Here we come to the end of lecture 8. In summary, redox reaction is transfer of electrons between chemical species. One species gets oxidized and the other gets reduced simultaneously. Therefore, oxidation without reduction is not possible, and reduction without oxidation is also not possible. Reduction and oxidation therefore goes hand in hand. Oxidation can also be defined as a process where there is an increase in oxidation number or addition of oxygen or removal of hydrogen. Reduction can also be defined as a process where there is decrease in oxidation number or removal of oxygen or addition of hydrogen. Any reduction reaction in the presence of light is called photoreduction. Here we have seen how benzophenone has undergone photoreduction to benzophenacol in the presence of isopropyl alcohol and toluene as hydrogen donor and N,N-dimethyl-aniline as electron donor. It is observed that photoreduction do not occur in compounds having electron donating groups, but occurs efficiently in compounds having electron withdrawing groups. That's all for today's lecture. Myself, Dr. Kakuli Lahiri, signing off, and will be back soon with the next lecture. If you like my lecture, please subscribe and comment. The links for the earlier lectures are provided in the description box. Thank you and bye-bye.